To ensure accurate positioning, we have divided our globe in different ways for different purposes. One such division is WGS-84, World Geodetic System 1984, a widely used global reference system. In this system, the points of the Earth are divided from the equator to the poles and from the prime meridian to the anti-meridian, between 0 and 90 degrees. This is used, for example, in GPS systems. However, for AutoCAD we use the also widely used UTM, Universal Transverse Mercator, projection system. In this system, the globe is divided horizontally from the anti-meridian 1 to 60 and from the South Pole to the North Pole AZ into so-called sectors. You can even switch or convert between the two systems in Google Earth. There are many other systems besides these. For example, if you locate the Vienna Opera House in Sector U33, the offices in Vienna use the so-called Gauss-Kruger coordinate system instead of the UTM. For this, first enter the UTM coordinates, then simply switch to the local system. I would like to present the basics of a survey Tippani drawing through a very simple example. Fundamentally, we receive the coordinate points from the surveyor, and they can be read from a CSV file as well, but since the focus is on understanding, we will create them ourselves from Google Earth. I pin needles on the four corners of a randomly selected building and use the coordinates obtained in this way for the drawing. I mark these points with numbers. I do the same with the property boundaries, and I mark these points with letters. I repeat, in this example, the accuracy of the coordinate points is not the crucial aspect, that is the task of the land surveying. For basic AutoCAD settings, use the A menu or the Units command. Since the UTM coordinate system is given in meters, it is advisable to set AutoCAD to decimal and within that to meters. I create one layer for the building and another layer for the cadastral boundary. The outline of the building should be magenta and the cadastral boundary should be cyan. Insert an attribute. Its position should not be locked. Create a symbol that defines the center of the measurement point. Create a block whose base point is the symbol marking the point. Open the Properties panel in AutoCAD and select the point. Also, open the Properties panel in Google Earth. Copy over the properties. The easting will be the X position of the point, and the northing will be its Y position. Find the point on the drawing and rename it as you wish. I choose the name given in Google Earth. Insert another point and do the same for the other points of the building. The coordinates can also be provided directly at the time of inserting the point. If you are ready with the points, select the building layer and connect the points. This gives us the outline of the building. A quick size check. You can see that although I am drawing based on an aerial photo, the error is only 29 millimeters. Create a new drawing with the same units and insert a point. I draw the cadastral boundary here to show how to join the two drawings. If it's quicker for you, you can copy the points, as long as the point names are unique. I follow the letters used in Google Earth. Once the cadaster boundary has been drawn, copy or cut it out with 0, 0 point and paste it into your original drawing with 0, 0 point. It can be seen that, knowing the reference point, the drawings can be matched with the precision defined in the units. So that entire cities, countries, practically the entire map of the Earth can be merged or broken down into parts. The points must still be placed on the corresponding layer. The areas can finally be named and accounted for according to local prescriptions. AutoCAD gives us many more possibilities, for example to make the data dynamic. Create an attribute for the number. And then for the type. Essential data is the area. You may need the perimeter of the object. And last but not least, the name or code of the owner of the object. Make a block from this. The center is not very important, but better not 0, 0. If you have drawn with a polyline, you can find the area and perimeter of the object in the Properties panel. These are properties that can be achieved dynamically. Open the Attribute Editor. Ctrl+F shortcut or right-click and select Insert Field. Select the object from the category. Select the object. And select the specific object. From the Properties row select the length, this is the perimeter of the object. As a suffix we can add the meter sign. The area query works in the same way, but this time we leave the suffix in the value field, so we don't have to add it separately. Dynamic fields are displayed on a light background in AutoCAD, so you should choose a color that makes the data more visible. Copy the block and do the same for another object. However, this time choose to edit an existing field. It's possible that here, instead of displaying the entire building plot area, we need to show the area without the building. In this case, this can also be done with a simple mathematical operation. Under the category of objects, select Formula. In the newly appearing panel, simply enter the formula, total plot area minus building area, and then press OK. It can be seen that AutoCAD calculates the area with the precision specified in units. We can also create an invisible layer on which we place, for example, source objects. Then, we connect the points with lines or polylines. Making it easy to read distances and other geometric properties from the panel, or embed them into fields, as we did with the area and perimeter. Surveyors can also provide elevations, which can be plotted by entering the z-coordinate in AutoCAD. It is very important to pay attention to the reference point given by the surveyor according to local standards. Examples are ASL, above sea level, in Europe, and IVD, Indian vertical datum, in Asia, but countries and cities may also have their own datum 0. By connecting the resulting points, you can also draw contour lines. Tippani drawings can include all kinds of natural landmarks, for example trees, rivers, and man-made landmarks, for example roads, buildings, or boundary lines and contours. Their exact position is determined during the survey. One of the great advantages of using attributes is that they can be organized into a table. For this, choose the Extract Data option on the Insert tab or use the Data Extraction command. We want to create a new table. Let's proceed. Save the table. Select the desired blocks, and in the case of a larger drawing, you can use the Select Similar command. Here, choose the Attributes Only option. Even so, many properties appear which we do not need. Let's keep the selection to Attributes Only. On page 5, you can see the structure of our table, with the possibility of some formatting. On the 6th page, you can export the table to an Excel file, but for now I'll just paste it in the drawing. At the end we paste the table in the desired place. If an area is modified, you can update the data in the drawing with the Regional command. The table data can be updated via the pop-up menu. The easiest way to insert a Google Earth image into AutoCAD is to draw a line on the image. Since the length of the line can be read from Google Earth, it can be used as a reference in AutoCAD. In this case, we need to place the background image on an exact coordinate, so this method is not sufficient for now. We need at least one coordinate point. Since we have already marked several points, a line will not be needed. Let's use the two furthest place marked points from each other. The others are not needed now, we can switch them off. Select Save and then Save Image. Then select the highest possible resolution. Finally, save the image file. Simply drag and drop the image file into AutoCAD and scale it to a size you can work with. Select it and use the Align command. If you have Object Snap turned on, turn it off, otherwise AutoCAD will easily take a different point on the image as the selected point. Click on the first point as precisely as you can. Then point to where it should land. Here it is a good idea to turn Object Snap on with F3. Then do the same with the second point. Then press Enter or right mouse button. AutoCAD will detect that scaling is required. Of course the answer is yes. As you can see, not only does AutoCAD do the scaling, it also rotates the image if necessary. You can also fade the image inserted as XREF data, which makes editing and proofreading easier. Thanks for watching.